Hey everybody, how are we doing there? Thanks for the introduction here. It's always a pleasure to be welcomed to give a webinar with ODSC. We thoroughly enjoy our time spent with you and your team and your community. But I'm Sean. I'm the head of developer relations here at Expanso, and we're a distributed startup with a team of people across the world from Tripoli to Seattle. And I'm joining you today from sunny London. Now, I know what you're thinking. Sean, it's never sunny in London. And you know what? You would be correct. But collectively, the British have reached the point of winter where it's been so long since we've seen the sun that the only way to cope is to begin deluding ourselves that it's actually, in fact, rather lovely here. But I digress. Thank you for joining me with our gracious hosts. And for this session, we're going to be talking about crunching your data in place with open source LLMs, open source large language models. So, what will we be covering in this session today? Well, first up, we'll take a little refresher on LLMs, where they're used, what kind of technology powers them, and importantly, their shortcomings. And then we'll take a look at Bacalhau, an open source distributed workload orchestrator that we at Expanso here maintain and provide people, and why we think it makes the perfect solution for tackling those LLM shortcomings without impeding on their core capabilities. And then we get to the part that I would wager that you're all here for, the demo. We'll use Bacalhau to deploy an open source large language model, specifically DeepSeek, but we can do others if time allows, and interact with it with your data on your hardware securely. And then finally, we will have a Q&A session where you can ask questions about how all this works, etc. I will be checking out the comments as things go on. If something is timely, then I'll answer that in line. Otherwise, I'll leave it to the end. So please don't think that if I haven't responded to you immediately, that I haven't seen it or not paying attention. Okay, a little bit of background. If you'd have to have been living under a rock the last few years to not have heard about LLMs in one way or another. The underlying technology that makes LLMs a possibility, though, isn't actually something that's all that new. And the kind of linchpin technology is the transformer architecture that was first described by Google back in 2017. And that itself was inspired by a now famous research paper which disagreed with the Beatles' core sentiment of love is all you need, and instead suggested that attention is all you need when it comes to generating text with machine learning. And what was so new and some would say radical in the transformer architecture is that it essentially replaced recurrent and convolutional structures with the notion of, for lack of a better term, self-attention. And at its core, this mechanism allows the model to weigh the relevance of different words in a sequence, regardless of their position in the text. So it can essentially kind of pick out and gauge what's important in a passage of text when it's evaluating it. And this makes it highly effective for generating what appears to be sensible outputs over a longer period of time. And unlike recurrent neural networks or LSTMs, that's RNNs and LSTMs, long short-term memory, which would process text sequentially, transformers can handle entire sequences in parallel, which can drastically improve training efficiency. So you have a model and an architecture which can rely upon or deliver shorter training times and generally deliver better results if you have the right kind of data to train them. But this is all the way back in the halcyon years of 2017, 2015. Why are we talking about this stuff so much time later in 2025? And it'll come as a surprise to no one. It's because back in 2022, OpenAI released ChatGPT, and we won't dwell too much on this because it's probably one of the most retold stories of our time. The rest, they say, is history. But here's the thing. Nothing in ChatGPT was particularly new or shiny. The techniques and ideas used to build those models had been around for well over 5 years. So it was it was by no means the first ever chatbot that anybody had ever seen either. So why did it take the world by storm? I actually dropped out of my sister's birthday party to check it out because everyone was going nuts on Blue Sky at the time. Well, it took the world by storm, in my opinion, for two key reasons. And first, it's actually quite good. I'd been working with AI systems at that point and chatbots for well over 5 years. And it was obvious to me, and I had to say that there was nothing really like it out there. Sure, you had like a bunch of NLU, natural language understanding technologies, which could pick out key bits from text, classify, and give you a related canned response, but it felt very packaged, it felt very safe. There were heavily established guardrails. But this was the first time that people could really feel like they were having a conversation. And they were having a conversation with a computer. You could ask a question and get what felt like a fairly well-considered response. You could argue with it, which I thoroughly enjoyed. I like a good argument, me. But that leads me to the second reason. It was accessible. It was available to people. Anybody could spin up the website and try this thing out, which, in some ways, I guess, felt revelatory to people. But it's exactly what separated Google from their competition back in the 90s. It was just incredibly simple to get going with. And you had this whole graph of information behind it that you could tap into and bend to your will. But if there was one downside to ChatGPT, it's that it's a proprietary system. There's no open source code. There's no way really to kind of peek behind the curtain and kind of see what's going on underneath, like what's pulling Pinocchio's strings. But good ideas rarely exist in isolation. If something great is put out into the world, but is put behind a wall, something magical happens 99.999% of the time. A great force rises to meet the challenge and break the technology from the box it's kept in. And of course, I'm talking about the open source community. And not long after ChatGPT came out into the world, open source large language models were an inevitability. There are vast swathes of people who love to tinker and give back to community. And those people started looking at how they might build the kind of functionality that ChatGPT has, but with the added benefit of being in control of how it's trained, where it's trained, on what it's trained, where it runs, and what it runs with. And at the start, in the early days, the kind of open source models that people were seeing, people putting out into the world, they were pretty good, but ChatGPT was still the king. However, a few years down the line, the open source movement has done what it seemingly always does, and it's pulled ahead in the race. And now some, if not most of the LLMs that are out in the world that perform best in whatever metric you choose to elect are open source. And those are some very attractive properties for LLMs to have for those of us who work in research and in organizations that want to embed their technology, this technology, into their services. You see, ChatGPT and others like it are great, but in order for them to be useful for our products, services, workflows, and processes, we really need to be able to augment those services with our data. And therein lies the rub, right? Data is precious, data is valuable. Importantly, data is governed by incredibly strong privacy laws, depending on where you are in the world. So you can't just start sending your company and customer data off willy-nilly to a server farm somewhere in California or wherever it is for processing with no insight into what happens to it when it gets there, what happens to it inside the system, and where else it may go on beyond your intended interaction. So having an open source model which can meet the capabilities of these commercial models, but it runs in your environment where you can track what it's doing and still get great results out of the model, it's an absolute no-brainer. But the question is, how do you do that? Whenever I see something new, the first question I have is, that looks great. How do I do this? What can I do with it? How do I make it run on my stuff? And I'm almost certain that more than a few of you tuned into this call have had to deploy a machine learning model or two in your time. And I'm also fairly certain that it won't have been as straightforward as you might have liked. The simple fact of the matter is that deploying ML models is a pain in the backside. And it's that way for a myriad of reasons, but you can generally break it down to one, or if you're really unlucky, all of the following. First up, there's a whole bunch of different systems that you may need to deploy your models on, whether you're running a particular version of Python, but your ML framework has a specific dependency which it isn't compatible with, or you need to do something crazy like deploy this stuff onto a Windows server instead of just our trusty old friend Linux. Or maybe NVIDIA's CUDA drivers just don't want to play ball today because Keras has been updated and they aren't quite compatible with CUDA 10.8 versus CUDA 10.7. All of these things add time and effort to getting the model to where you want it to be, and it's a pain. it's a pain. You may have to deal with internal processes that ensures you're allowed to get access to those systems that you want to run the stuff on in the first place. A lot of us, and particularly myself, we have been spoiled by cloud computing. It enables us to spin up potentially huge instances in next to no time at all to run our workloads. But that's not the case for a ton of people. Whether you have to log a ticket with the IT department to get some infrastructure provisioned for you, or your software that you want to use or you want to write needs to be audited by security ops first. Again, this just causes delays. This gets in the way of just doing what you want to do, which is run your model somewhere in your infrastructure. And then there's a question of getting access to the tool itself. Once you've got the model up there, how do you control who can access it? Where do you track who did what where? And where do the logs for those interactions go in case you need to audit them later? It's an incredibly important step in any sort of system run a large organization with people's data. And then there's the final hurdle. How do you update that model? Let's say you get the first model you want to get running going. What does the process look like to update it when things change? Nothing in this world is static, AI especially. And what's cutting edge now will soon be old and comparatively antiquated alongside the new stuff, just like me. But do you have to go through all those previous steps again to get to this point? And if you do have a simplified process for having done it the first time, how do you then manage one or more models running on the same systems? And all of these hurdles eat up that most precious of resources, time. But we think we have a solution, and that's where we get to Bacalhau. You see, Bacalhau is a distributed workload orchestrator. That is, it's designed to do one thing and one thing really well, and that's get your applications to where they need to be to work directly with your systems and your data on those systems. And we call this approach compute over data. The acronym there is COD, and for those of you who don't speak Portuguese, Bacalhau is Portuguese for COD, so it's a little in-joke there. But essentially, Bacalhau was built with data security in mind. When we look at the vast majority of infrastructures that people have built over the last however many decades, they're usually designed to take data where it's generated, which in the vast majority of cases is at the edge of the network, on devices, so your smartphones, your cars, your thermostats, individual computers, smart bus stops. And then they take the information and they forward it on to some central location en masse, like S3 or a data warehouse like Snowflake, for example, and then they process that later on. But that's horribly inefficient for a bunch of different reasons. The first is there is a lot of data to move across the network. According to, I think it was Gartner, this year humanity will generate something like 181 zettabytes of data and move it across the internet. And if you're not familiar with working data on the zettabyte scale, 1 zettabyte is 1 trillion gigabytes. And so 181 zettabytes is 181 trillion gigabytes of data that's going to be generated and moved this year, 2025. Moving all of that across the network just to understand what's going on in it and derive insights from it that we can use to make decisions, it's just not scalable. It takes time and it costs money. And it costs a great deal of money to store data at that kind of scale. And it costs even more money to pull that data out of the warehouse to work on it. Egress fees are one of the pet peeves of my life and one of the few things in modern networking infrastructure that causes me great deep anxiety whenever I spin up a data science project. And we think it's crazy to pull in gigabytes and terabytes of data to a system when all you really want to do 9 times out of 10 is run a query over it. With Bacalhau, you can simply describe any kind of task you want to run over your data, compute over the data, bundle it up with the code, and then ship it directly to the computers that have data you want to work on, regardless of where they are or what kind of system it is. So instead of pulling in gigabytes from every which system you want to work with, you can push out megabytes of codes and dependencies and run them directly on the data in all of the locations you want to work with, either in isolation or in parallel, because it's cool like that. And you can pull back just the results from those jobs. It's cheaper and it's faster and it's more secure. You can keep data where it is. You can keep it in those environments that it's already in, and you can still get the insights that you can make decisions based on without having to move them anywhere or get approvals beyond the normal approvals you would already have. And let's talk about security for a second, actually, because that's part of why we're here, figuring out how to run LLMs securely on your data in your environment. How do we run LLMs in our environment, but make sure that they're only working with the data that we want them to, and that it's not being egressed somewhere else on the internet? It's all well and good being able to get it. You want to make sure it doesn't go somewhere else afterwards. And that's what Bacalhau does supremely well. When you run a job, a system with Bacalhau, you are able to define and strictly enforce what parts of the system that job has access to. And importantly, whether or not the data can be egressed to some other location. And this makes it fab for doing things like ETL or log processing, where you can send along a job, find only the important bits of the data you want to know about, process that, and then send that subject on for further analysis to a specific location for further analysis. But here's the thing, these qualities are also perfect for running secure LLMs in place. Because you see, Bacalhau is workload agnostic. It's not opinionated about the kind of workloads you do. So while it's commonly used to take a Python script and ship that off and do some analysis, or run a SQL query across some distributed SQLite databases maybe, you can also, if you can bundle it up as a container or compile it to a WASM module, then you can run it with Bacalhau. It's incredibly compatible. And LLMs can be trivially containerized. And so that's what we've done. And this is where kind of DeepSeek comes into the picture. We've actually been working with large language models for quite a little while now, well before DeepSeek R1 kind of hit the market, because we recognize that all of Bacalhau's characteristics make it a natural fit for running LLMs. So when we first built it, we were actually working with Llama 3.2, which was the best-in-class LLM at the time. But again, nothing is static in this world. And DeepSeek R1 hit the scene 3-4 weeks ago now, and it's completely upended the science of machine learning world. And why did it make everyone go a bit nuts? Well, it could compete with the best-in-class commercial models. So again, there's always been a little bit of a lag on commercial models and then open source models, right? Where there's a company that has millions or billions of dollars in compute available to them. They can crunch these huge models and then throw them out in the world, brute force the training of those models essentially. And then the open source community trying to figure out a way of getting that same result, but on vastly simpler and smaller hardware. But DeepSeek was, I think, a week after the ChatGPT 01 model came out, DeepSeek hit the market. And it was trained on vastly cheaper deep learning hardware than competing models. So all of a sudden, needing hundreds of millions of dollars of NVIDIA GPUs becomes actually you just need a few $1 million, which is still a lot of money, but it's vastly smaller and accessible to people that want to go and do this if they're in these organizations that have this kind of will in this kind of direction. And importantly, it was a reasoning model. So we'll look at this a little bit later on. But when you have a large language model up to, well, the start of this year, really, which seems like a lifetime ago now, was it week 6 of this year? But you had a large language model up to the start of this year. You would input your query, something would happen in the background, and then you would get the result. There was no real way of kind of peering behind the curtain again and seeing what was going on in there. And we couldn't really kind of see what the model was, for lack of a better term, thinking about. They don't actually think, but it gives the impression of it. A reasoning model essentially shows you kind of what's called a chain of thought. So it takes your query, it then evaluates the query with what it thinks are the expectation and the important parts of what you're asking for. And then when it goes to generate a response, it considers all those things and then kind of outputs what's going on there. So they're incredibly powerful for doing, again, these kind of focused, nuanced pieces of work that whilst other older models were very, very good at, we now, again, we just get a little peek behind the curtain. We can kind of see the bits that it thinks are important. And that helps us augment what it's doing, helps get a better sense of what's going on in there. And I'm sure that people that are working and training these huge models probably use that in some clever way to enhance the results come out of it as they build these new things. So for those 4 reasons, I would say everyone's LinkedIn the world over went absolutely bonkers. And that's because it's really simple, and because it's really simple to change things in the Bacalhau job. Switching out Llama 3.2 for R1 is trivial. And so that's what we've gone and done, and that's what we're going to show you how we did today. So yeah, it's nearly demo time. Let's take a look at a bit of the infrastructure that we are going to be looking at today. So this is the application that we have put together. Whoops, there we go. That we have put together. So essentially, you have your computers here, which can be in your secure environment that have your data on them. So they don't have network access, it's only outbound. They don't have, they're not open to the public internet as a rule, and your data is in place. And each of them, we've installed the Bacalhau client onto. So there are 2 kinds of nodes in the Bacalhau network. There's the orchestrator, which allows, kind of manages the network of different nodes and says, hey, I want to put this workload in this place. And then there are the compute nodes. And the compute nodes are where those executions actually happen. So on each of these machines inside our secure environment, there is a Bacalhau agent which is able to talk to the orchestrator and say, hey, I have a computer, I am available for workloads, I have these capabilities, and these are the directories that are open to you, not to the internet, to you specifically, to work on if you want to. And in this case, it's really, really simple to spin up a compute node, an orchestrator node. It's 2 CLI commands, 1 for each one, that just hook them up, and then you're able to dispatch jobs to any other computer in the world. But we are big fans here, Expanso and at Bacalhau, of trying to remove as much complexity as possible. And so we've actually just launched a managed orchestrator platform very recently called Expanso Cloud, which is the functional kind of core part of this network here. So in a moment, you'll see that I run a CLI command. It'll hit the orchestrator in Expanso Cloud and say, hey, of all the nodes you have available on the network, I would like you to run this job, please. That job is going to be our LLMs, which execute on that device. And just keep an eye on them. Restart them when they fail and make sure it gets to all the nodes when they're available, if they have the capable compute. And what's beautiful about Expanso Cloud is it's secure by default, so it's end-to-end encrypted, it's working over TLS. It's about as secure as communication can get there, and you only need to have open, I think, 3 ports for it to get working with. And it's free. There's a link at the end of this. Do go and check it out. But then we have this other little application over here, just a simple Node.js app, which sits in the public cloud. So when these Bacalhau jobs, which contain a large language models, load up on the system, they do essentially reverse proxy out to a public server over WebSockets. Which says, hey, I am available now for you to interact with the system. So no data is leaving that system. Again, it's encrypted end-to-end, everything's staying in place, but the conversation is happening over the public internet from that secure environment that's still pretty much impenetrable. So yeah, that's what we're going to be doing in just a little bit. How have we done this? Well, we've used 2 core tools. Again, open source is creates some of the finest technology in the world. And so when we see something that's great and we want to work with it, we go and build things with it. And one of those things is Ollama. So for those of you who are not familiar with Ollama, essentially it is a tool which enables you to run models in a simple, unified way on your system. So you, much like in the way you might pull down a Git repo or an NPM module or a Python package, you can do something along the lines of like Ollama run and then DeepSeek or Llama 3.2 or Small Thinker from Microsoft if you're looking for a really small model. And Ollama kind of abstracts away the complexity of running those models, just makes it really simple to get going. And so it has an API, which is great. So what we can do is then essentially wrap up Ollama inside a Bacalhau job, ship that off to our nodes where it exists in the secure environment. Ollama can work on that data. It can't go beyond the data. And the little Node.js application, which is speaking with Ollama via the API, can then proxy out the messages between those 2 things. So again, no data is leaving that source. It's just where it is. But that's enough talking. I think I've been going on for about 20, 25 minutes now. Now it's time for the demo. So yeah, I'm just going to switch over my screens real quick. Yeah. So the first place we're going to start is we're going to look at Expanso Cloud. So again, this is the place where all of our orchestrator exists. So this is kind of the central point that Bacalhau can interact with compute nodes on the network. You see, I actually have two networks. We actually run a machine learning bot network on Blue Sky, which you can go and interact with and do things like hot dog, not hot dog, or generic classifications with old school CNNs, convolutional neural networks. So go check that out. But today, we're interested in the DeepSeek demo network, this demo network that I have here. And you can see in just a second that we have, I think it will have two compute nodes fired up there. So what we've got are two very large EC2 instances running over in our corporate AWS account, which has a couple of Wikipedia articles on each one with information about, I think, three of the great cities in the UK, three great cities, London in the UK, Boston in the United States, and Luton, my hometown, because, hey, you've got a rep, right? So yeah, and the other one has a collection of Wikipedia articles on the inner solar system, so Mercury out to, and I think including Jupiter. Although I don't think Jupiter is technically part of the inner solar system. And so what we're going to do is we're going to say, hey, these nodes which have this data, we want to push out a job to those instances and say, hey, go and do this, please, and run this LLM over this data in these different places. And then we have that little web UI I've put together, which just interact with that data. So let's take a little look at the kind of code that's going on here. Yep, here we go. Yeah, there's a lot of things to show here, so there's going to be a lot of screens changing over, but I'm more than happy to walk through this stuff at the end if they would like. So let's take a look. Yeah, so at its core, it's just a very simple Node.js application which gets containerized. We have a tiny RAG which essentially reads the files on the system that Bacalhau allows it to, so you couldn't do arbitrary file reading. It's looking for very specific files in very specific places. If it tries to read content beyond that allowed directory, it's going to fail. It's not going to be able to read it at all. It's partitioned off. Loads it up with a RAG, and then uses the Llama API to fire up the chosen model that we might have. I think there are 4 or 5 models on each system, so Llama 3.2 and DeepSeek and whatnot. And then it will pass queries along with that RAG into the conversation and keep track of that transcript over time, so we can have a continuing conversation with those local models on those remote systems. And importantly, it's how do we get this thing up to our system? And it's really simple. It's just a Bacalhau job file. So it's a YAML file which describes the kind of information that we want to have our job to have access to. It describes a container which contains our Node.js app with a Llama and the models and whatnot, and some of the variables that we want to be able to hit to go and do these things. So I think now we can just let's just spin that job up. If I stop sharing real quick and bring up my terminal. Yeah, cool. Share screen, window. Yeah, so we're in the directory now that has that job file, and it's incredibly simple. Again, when we talk about distributed systems, we know they're complex. We know they can be very hard to understand. We know they can be complicated. We've worked really hard to make Bacalhau the best in class at having a great developer experience. So to run those LLM nodes, there's LLM programs on all of our nodes and networks. So there's 2 big AWS instances. It's literally Bacalhau, job, run, and then job.yaml. That YAML file we had a second ago. It's going to spin up. That's all secure. Those are executing now. If we head back over to Expanso Cloud, we can see that those jobs will be running on each node. And there it is, 14 seconds ago. Right, that is now that job running in the background. So the containers have been deployed to those instances. They are now running on those systems, and they are ready to receive input from our UI. So let's fire up the UI. So we should have a tab. Here we go. So you can see right now that there is nothing showing on here. This is our little web UI that reverse proxy from the WebSocket again. But as the job spun up, if I refresh this page, I should get 2 extra nodes. So as I said, one EC2 instance has information on places, and one has information on planets. So let's go through to the planets node, and yeah, it's selected DeepSeek R1 with 7 billion parameters for it. So we don't have infinite resources to run the 400 billion parameter model, but we do have the ability to run a 7 billion model, which is very, very able to do things. So the first thing I'm going to do is I'm just going to ask, what kind of files do you have access to? What of files do you have access to? So again, that RAG is going to get loaded in. And it's going to take a couple seconds to think about it. It's going to take about 20 seconds to do it there. Harshit, in answer to your question, are you guys using Llama instead of DeepSeek or OpenAI, or is it a combination of a Llama and DeepSeek? So we're not using OpenAI at all. None of this is happening in a commercial cloud environment. All this is happening on the systems that we just deployed the Bacalhau job to. So we're using the open source version of Llama and the open source version of DeepSeek, which you can switch between and choose, and we'll show in a little bit. And so what's happening now is all that information, all those Wikipedia articles are being kind of hoovered up by our Node.js application. It's deciding, basically eating up a lot of memory right now, loading up a lot of the memory, and you can see that it started thinking. So we haven't quite passed the markdown, but this is it, working through that first stage of, it's doing the reasoning. What has the person asked me? It's asking about the files. Okay, what files do I have access to there? And that's where it's using that RAG to understand that content. And so this is it still figuring it out and summarizing it for itself. And then in a second, it will finish thinking, and it will answer my question. And that will be limited by a closing tag of end think. There we go. So that's it done this thinking, and it answers my question of what files you have access to. It's like, I have access to these following files: one about Earth, one about Jupiter, one about Mercury, Venus, and other bits and bobs there, which is really great. So when that's finished processing, we'll ask it some follow-up questions, I think, just to show this isn't a one and done. And then we'll switch to the places node, and we'll ask that some questions too. So, and again, none of this information is being passed around. This is us having a conversation that's happening on that remote system. It's not being run somewhere else. It's not being used in the cloud environment. It's being run on my system with my data that can't be egressed in any sort of way. And God, it's being very thorough, this 7 billion parameter model, isn't it? Hang on. Never worked with, animals and AI. There we go. Cool. So it's finished answering the questions now. So let's say something along the lines of, what's my favorite planet that isn't Earth? I think Venus is the most interesting. Give me a fun fact about Venus. And it'll be a lot quicker this time because it's kind of done that initial loading of all those files into memory, and now it's just going to go straight to the reasoning stage and the answering stage. But again, it's continuing the conversation. This is a thread that's happening there. It's ephemeral, so as soon as I close this window, this conversation is gone. I can't say to it, hey, give me all of your files en masse to kind of get the content there. It'll interpret a lot of it, but if the RAG is doing its job as well, which is something that is developer controlled, then it shouldn't use its existing information as well there. It should just be deriving that content from the information that's in those files. But yeah, this is it, thinking about all the facts of Venus that it is aware of that are in those opening paragraphs of the Venus Wikipedia page. And so now I guess going to think about, well, what's fun? Yeah, here we go. That's me, Desert Nerds. Yep. I'm actually learning a lot about Venus in this moment. I'm seeing some great questions coming in from everyone there. I will go through all of these at the end. I'm just going to let this bit run through itself first. Hang on. Ravakumar, just to answer your question about Bacalhau handling scalability. Bacalhau can use all the resource available to it on your host system. So if you have a huge workload and you want to process that in a single job rather than parallelizing it, then it'll be on a big computer in the same way that you can also, like it would run any other Python or JavaScript program there. Bacalhau makes sure that job gets to where it does and can run on the resource that it has available to it. But we can talk more about the ins and outs of that in a little bit. So it was my fun fact. My fun fact is Venus once had a habitable environment with trace of liquid water thought to exist in its thick sulfuric acid clouds. That's cool. I didn't know that. But that's enough of this conversation. Let's go to my other node. So I think one is based in London, one is based in Virginia somewhere. And this time around, I'm going to switch to, let's switch to, ooh, will I be able to handle llama? Yeah, let's give llama a go. Let's see if that has it. So again, what places can you tell me about? Can you tell me about? I don't know if this is going to be like one of the huge models I've loaded into this thing, so this might take a little while. So give it a sec. And so llama is not a reasoning model. It is very simply just an LLM. So it's still going to be loading all the information into its memory to kind of get a sense of what's going on there. But it's not going to do that kind of reasoning stage. It's just going to do a straight answer from what's got there. So it's going to work through once it's got this in memory and then give me the answer rather than the reasoning. But I'm going to show you why that's important in a second as soon as it's finished doing its thing. Another thing to consider here is that this isn't running on GPUs. Open source models can run very competently on normal CPU infrastructure. We're running, admittedly, two fairly beefy AWS instances, but this stuff can run on my Mac and it can run on Raspberry Pi as well. But importantly, Bacalhau does enable you to use underlying GPUs to run these kind of workloads without any kind of real configuration there. It just kind of works out of the box, which is particularly nice. So yeah, good at generic deep learning training and inference as well. Ooh, it's still working through it. I think this data business has been caught napping. I have faith. I have faith that this will work, but I'm going to give it another 10 seconds and I'm going to give up on it. Oh, there we go. Right. So it knows about London, as I said. It also knows about Luton, again, my hometown. What? Which, yeah, that is the population of Luton. It's one fun fact about Luton. It's one of the largest towns that isn't a city in the UK. It's about 30 miles north, 40 kilometers north of central London. So in the 34 years I've been on this planet, I have managed to travel a grand total of 30 miles from home. But yes, and finally, it has about Seattle in there. Seattle. Yeah, okay. So it's got that a little bit wrong, but whatever. Let's ask the question. Tell me, are there any commonalities? Are there any commonalities between Luton and London? I'm curious what's going on there. And see, now that it's loaded that information into memory, it's much, much faster about getting going. And we're using this for fun facts and general queries about data sources, but you can use this for CSVs, you can use it for pretty much any kind of file format. Some models even have the ability to do kind of vision processing that the can do these days. So it's just a matter of what can you build to work with the kind of data that you want to use. And again, Bacalhau enables that to happen in that secure environment in place in real time. And yeah, very cool stuff. Now, I'm going to take a risk here. I'm not going to switch the model while it's doing the answers, but I'm going to switch now to, let's go to small thinker, because it uses a little bit less memory, a bit quicker. Tell me about Seattle. So this is a vastly smaller model. It shouldn't take so long to load everything to memory to answer questions that I've just asked it. But I have essentially just hot swapped those two models there. So nothing's being redeployed, they're just being switched over now. And so whilst it's a new instance of a large language model being instigated, I'd have to reconnect the instance. I can't remember if it's tracking the conversation. I don't know if I programmed that bit into it, but it should just be able to go, soup, absorb the information and give me the answer that I'm looking for, or at least that it should be rather interesting. For those who don't know about Small Thinker, it's a very, very small large language model, of which there are more and more of them each day. I think it was produced by Microsoft, I can't be sure. But essentially, it's 1.5 billion parameters. It's really quite good at doing good output with very little compute resources. So this is the kind of thing that you might go and run on a Pi, for example. But just give it a sec to kind of get that all into memory, and we'll then carry on. Then we'll wrap up and we'll give people the opportunity to ask for questions. I feel like I should have like a little finger puppets or something to pass the time. We're doing it there. Let's see if there are any other questions going on. So in the Bacalhau test environment, can we connect streaming data sources? By that, Jay, do you mean like can you stream files from the operating system, or do you mean something more along the lines of like handling some of the other WebSockets or RTC? The answer is yes. The long and the short of it is, if you could do it on a normal server that isn't locked down, then you can pretty much do it with an application in Bacalhau. Bacalhau you can think of as a layer that goes around your application and kind of stream a file from mine. Yeah, absolutely. But you can think of Bacalhau as kind of like a sandbox environment almost, which gives very specific enabled functionalities. So that is, yep, that's working now. So again, much smaller model, it's loaded in, but I've hot swapped that on the fly. Took a little while, not a huge AWS instance. And again, if it had a GPU enabled, it wouldn't have taken any time at all. But this is now a separate model that's running on that same data that I gave access to previously. So I haven't had to redeploy anything. I haven't had to do anything that's like told it to update. Literally, what's happened there is I have written a little bit of code that uses the WebSocket to say, hey, I want to use this model now that goes into that Bacalhau instance where that LLM job is running. It gets that message, it's cool, I'm going to hot swap this out now. And it just does it through the Alarm API. So again, this is not something that's like unique to Bacalhau built into it. I have just made that go into it. And again, this is a 1.5 billion parameter model. It's doing quite an impressive output for a very small model. Tell me about London in 500 words or less. Yeah, now it's ready to go. It's warmed up. And that's pretty much the demo. Again, we ran one CLI command and we were able to deploy all these models to work in place securely on this data. There's no limit to what can be done with it, but this is something that we put together back in, I think, December. It took me maybe 2 days to build this system. Bacalhau was by far the easiest part of it. The hard part is CSS to make this look halfway decent. But yeah, I think we'll wrap it up there and we'll move to answering questions. So if I stop sharing my screen, let's take a wee look at what we've got here. Hold on. Yeah, okay. So just going to put something up for you all. We love to chat over at Expanso. If you have a question or you want to spend some time talking to myself or some of my colleagues, then we are always more than happy to speak with people.